Now I want to discuss with you that how we decide that what is the method of finding the zeros of any quadratic polynomial. Because in case of the if I want to find the zeros, so I will take ax plus b is equals to 0. Ax plus b is equals to 0 gives us x is equals to minus b upon a. That is, x is equals to minus b upon a is the value, x is equals to minus b upon a is the value which can make this polynomial as 0, and necessary condition is a is not equal to 0. It is linear, so it has 1 zeros. But now I want to explain you every quadratic polynomial has 2 zeros, and what is the formula for finding those 2 zeros. That is, if ax square plus bx plus c is the quadratic polynomial provided a is not equal to 0, then with the help of these coefficients, how can I tell you what are the 2 zeros which can make this entire polynomial as 0. So these values are, the first value of x is always given by minus b plus root of b square minus 4ac upon 2a, and second value, this is first value of x, and the second value of x is given by minus b minus root of b square minus 4ac upon 2a. So if we have any quadratic polynomial, obviously we have 2 zeros. What are these 2 zeros? There are 2 approaches, one by the method of factorization and other by the direct formula. Direct formula is minus b, where b is the coefficient of linear term, plus root of b square minus 4ac upon 2a. A is the coefficient of the square term, c is the constant one, and if this plus is replaced by minus, then it gives us the second value, and we also say this is alpha and second zeros is beta. Now I will take some examples to calculate the zeros with the help of these formula and by the direct. Now I want to explain you by taking one of the example that how we can calculate polynomial. Suppose I say 2x square minus 3x minus 2. It is one of the quadratic polynomial. You want to find 2 such values of x which brings this result, this polynomial, as 0. Suppose you want to factorize, that is 2 2s are 4. For 2 into minus 2 minus 4, because first of all we need to calculate the product of these two, minus 4. For this minus 4, we need to take 2 such values whose product is minus 4, but its difference should be what? Minus 3. These values are minus 4 into 1. Their product is minus 4, but minus 4 plus 1 gives us equal to the middle term. That's why this method is known as the splitting of the middle term. I can say 2x square as it is. 2x square as it is, and I am splitting this middle term minus 3x by 2 of the values minus 4 and 1. This becomes minus 4x plus 1x minus 3. I can make the pairs, and this is 2x, so this becomes x minus 2. From this is 1, x minus 3. If I take here, this value is basically minus 2, so I need to write here minus 2. This is also minus 2, so x minus 2 is the same, and then left is 2x plus 1. So you can further explain that every quadratic polynomial is the product of 2 linear polynomial, which is very much visible to you here. 2x square minus 3x minus 2 has been expressed as the product of 2 linear polynomials. So in other language also you can define that what is a quadratic polynomial? It is a product of 2 linear polynomials. Now with the help of this and this, what implies we get the values of x which can make it as 0 are 2 and minus half. Hence, we can conclude that this quadratic polynomial, whose degree is 2, that's why it is quadratic, having two zeros, 2 and minus half, which you can verify by successively putting once x2 in all, you will get 0. Once in place of x minus half, you will get 0. So, if the zeros are given, you can verify that whether these answers are correct or not, because if these are zeros correct, then these corresponding values must make any polynomial whose zeros are these as 0. Now I will explain you the same question with the help of our next method, that is the direct method. Now I want to tell you the same question. The same problem, that is 2x square minus 3x minus 2 is a quadratic polynomial, and once I told you its zeros are 2 and minus half by the method of splitting the middle term. But if I want to calculate by the method of formula or directly, if in some cases it is not possible to split middle term, then our method of applying the formula is very important, very useful, and gives the correct answer. So for that, what are the steps? You be with me, I will explain you. First of all, you can say that the standard form of the quadratic polynomial is ax square plus bx plus c, provided a is not equal to 0. You can take, compare a is 2, b is minus 3, c is minus 2. If a, b, c are these values, then you can go to calculate one of the important result, which is so-called discriminant, represented by capital D, and value of the discriminant is always in every quadratic polynomial is b square minus 4ac. That result comes, b square means minus 3 square, that is 9, minus 4ac, that is 4 to the 8, 8 to the 16, negative, negative, positive. So the answer is coming out to be 25. The answer of b square minus 4ac, or the discriminant you can call, is what? 25. What is the formula for finding the two zeros? One of the zeros is symbolically named alpha, or you can say x1, and formula is minus b plus root d upon 2a. What is minus b? We have b as minus 3, so minus b's answer will be plus 3. Plus root d, 25 is the d, so root d is 5. Upon 2a, that is 2 to the 4. So this becomes 5 plus 3, 8. 8 upon 4, first zeros comes out to be 2, which also 2 in case by the method of splitting, which previously I explained you. Second zeros is beta, or can say x2, and formula is minus b minus root d, where d means, in shortcut, the value of b square minus 4ac is symbolically written as capital D. Upon 2a, so this becomes 3 minus 5 upon 4, which gives us the answer as minus 2 by 4, or you can say minus half. So ultimately you can apply any of the method, but you will come to notice that the answer of zeros in both the cases for the quadratic polynomial comes always same. So especially you will apply this formula when you are helpless in factorizing, or you don't want to apply the formula, or you are bound to apply as per requirement of question that find the zeros by using the formula. Now I will tell you the relation between zeros and the coefficients of the quadratic problems. Now I want to explain you the relation between the coefficients, that is the coefficients of the quadratic polynomial, and its zeros. If I take an example like this, that is 3x square minus 7x plus 4, it is definitely what is a quadratic polynomial. If I compare it with the standard one, ax square plus bx plus c, provided a is not equal to 0. I can say answer of A is 3, coefficient B is -7 and constant C is what? 4. Here you must understand one more thing. What is the difference between coefficient and constant? -7 is the coefficient, 3 is the coefficient, 4 is the constant. Constant is not the attachment, whereas this -7 and 3 are the attachments. So these are the coefficients and this is the constant. If I ask you to find what are the zeros and what is the relation, if I tell you in very much detail, the first zero alpha is always given by -b plus root d upon 2a, and second zeros is given by -b minus root d upon 2a. If I ask you to add, that is alpha plus beta, you will come to notice that minus root d and plus root d will cancel. How? -b plus root d upon 2a plus -b minus root d upon 2a. LCM is what? 2a. This becomes -b plus root d minus b minus root d. That becomes -2b upon 2a. That's why I can say this is -b upon a. So remember, sum of zeros is the value negative of the b upon a. Whatever is b, whatever is a. In this case, if I ask you if there are sum of its zeros, that is, this polynomial will definitely attain 2 zeros. And if I ask you what is their sum, so sum of zeros is given by the formula minus b upon a. That becomes minus of -7 upon what? 3. That is, sum of zeros of this quadratic polynomial will be 7 by 3. If I ask you what is the product of zeros, the formula for finding the product of zeros, if you will multiply alpha and beta, that is -b plus root d upon 2a to -b minus root d upon 2a, then the result will come out as c upon a, and that value will indicate 4 upon 3. That is, c is 4, a is 3. So there is a relation between the coefficients and the zeros. What is that relation? For finding the sum of zeros alpha plus beta, it has the relation -b upon a, and product of zeros is given by -c upon a. It is always true, which you can verify by calculating its zeros by any of the method, by the formula or by factorization, and then you can check whether these two zeros, these two relations are true or false.